Most indie beginners movie player, but many don't actually know what's happening behind the scenes. The character moves, the game runs, everyone is happy. But what about the actual code? Completely mysterious. So let's fix that today. Right now I am in the Unity scene. When I move this player object, look at the transform component. See the position values changing. If the X value changes, the player moves left or right. If the Z value changes, the player moves forward or backward. And the Y axis is usually used for height, like jumping. So in simple terms, moving a player in Unity just means changing its position values. But imagine controlling your player from the inspector like this during gameplay. Press play, move X, move Z, stop, change again. If you are doing like that, congratulations, you have just invented the world's slowest game controller. So instead of this, we'll add the keyboard to control the player. And Unity already helps us with the something called input axis. If I open the input settings, you will see horizontal and vertical axis. Horizontal represents A and D, or the left and right arrow keys. Vertical represents W and S, or the up and down arrow keys. Basically, Unity already understands what keys we want to use, which is nice, because typing every key manually would make the script about 300 lines long. Now let's write the script. First, I will create a new C# script called player movement and open it. First, I am declaring the speed to say how much speed the player need to move. And after declaring the speed, inside the update function, we will start reading the input. First, we store the horizontal input. For that, I will write float x equal to input.getAxis horizontal. Now you might ask, why am I using float and not int? Because Unity does not just give values like -1, 0 or 1. When you press a key, the value smoothly increases. It might go from 0 to 1 from decimal values, and only a float can store decimal values. If we used an int, Unity would basically say decimals. Never heard of them. Now let's read the vertical input. For that, I will write float z equal to input.getAxis vertical. Now we know we are taking only the inputs but not moving anything. Now let's see how to move the player with these inputs. For that, I will write Transform.Translate of x into speed into time.delta time, comma 0, comma z into speed into time.delta time. Here translate simply means move the object from its current position. The x value controls left or right movement, the z value controls forward and backward movement, and speed controls how fast the player moves. You will also see time.delta time here. This makes sure the player moves at the same speed on every computer. Without it, on a fast computer, your character might run like a superhero, and on a slow computer, they might be more like they just woke up from a nap. Now we need to attach the script to the player. So we go back to the Unity, select the player game object, and drag the script onto it. Now when I click on play button and clicking on keyboard, you will be able to see that player is actually moving. But there is another important component we should talk about, and that is rigid body. If the player doesn't have rigid body, Unity physics system won't affect it. That means things like gravity and realistic collisions won't work properly. So usually we add a rigid body component to the player, so Unity physics engine can do its job. But here is the interesting part. The method we use at Transform.Translate directly changes the position instead of letting physics handle the movement. Let's understand that with a real life example. Imagine this toy is our player. When I move the toy like this, I am directly changing its position. That's actually what Transform.Translate does. But if I push the toy like this, it can go straight through other objects. No collision, no resistance. The toy just says, "Excuse me physics, I am going through." The same thing was happening in Unity because Transform.Translate ignores the physics system. And physics is extremely important in games. Physics handles collision, gravity, and interaction between objects. Without physics, player might walk through walls, which might be funny once but probably not the feature you were playing. That's why developers often use other movement methods instead of this. They are Rigidbody.AddForce, MovePosition, or CharacterController.Movement. Each of these works differently and is useful for different types of games. In today's video, we are going to learn how to move a player using AddForce in Unity. This video is very useful when you want movement to feel more natural, because instead of directly changing the position of the object, we apply force and let Unity physics system handle the movement. Now in the previous video, we moved the player using Transform.Translate. That method directly changes the position of the object. It simply and works well for some situations. But when we want movement that interacts properly with physics, we usually use rigid body forces. And that's exactly what we are going to do in this video. So let's start by creating your script. Go to the project window, right click, select create, and then choose C# script. I am going to name the script as player moment. Once the script is created, open it. Now the first thing we need is a variable that controls how strong the movement should be. Because when we apply force to the player, we need some value that decides the strength of that force. So for that I am writing this line of code. Public float move force is equal to 10F. This variable is called move force, and it simply decides how much force we apply to the player. If this value is small, the player will move slowly. If we increase the value, the player will move faster because more force will be applied. Now the next thing we need is access the rigid body component for the player. The reason for this is very simple. The AddForce function works with rigid body physics. Without a rigid body, we cannot apply physics forces to an object. So for that, I am creating a variable that will store the rigid body. This variable will hold the rigid body attached to our player object. But right now, this variable is empty. We still need to get the rigid body component from the player. And the best place to do that is inside the start function. Because start runs once when the game begins. So inside the start function, I am writing this. RB equal to get component rigid body. This line is used to find the rigid body component and stores it inside the variable RB. Now our script can access the rigid body component and apply physics forces to it whenever we want. Alright, now that we have access to the rigid body, the next step is to write the movement logic. For movement, we need a function that runs continuously while the game is running. Normally we use update for things that can run every frame. But since we are working with physics here, it's better to use fixed update. Unity performs physics calculations inside fixed update. So for that, I am writing the fixed update function. Now inside the function, the first thing we need is the player's input. We need to know which direction the player wants to move. Unity already provides an easy way to read movement. Input using input.getAxis. So I am going to write these two lines. Float horizontal equal to input.getAxis horizontal. Float vertical is equal to input.getAxis vertical. These two lines read the player's movement input. The horizontal axis controls movement to the left and right, and the vertical axis controls movement forward and backward. Unity automatically maps these axes to common movement keys. So when the player presses movement keys, these values will change between negative and positive values, depending on the direction. Now that we have the input values, the next step is to convert this input into a direction vector. In Unity 3D, directions in 3D space are represented using vector 3D. A vector 3 contains three values, x, y, and z. The x value represents left and right movement, the y value represents up and down, and the z represents forward and backward movement. Since our player is only moving on the ground, we don't want any vertical movement, so the y value will remain 0. So for that I am writing the following. Vector 3 movement is equal to new vector 3 horizontal 0, vertical. What this does is creating a direction based on the player's input. If the player wants to move forward, the z value will increase. If the player wants to move left or right, the x value will change. Now that we have the direction, the final step is to apply the force to the rigid body. So the player actually starts moving. So for that I am writing this line. RB.AddForce of movement into move force. This line applies force to the rigid body in the direction we created. The direction vector is multiplied by force, which controls how strong the movement should be. At this point our script is complete. So let's go back to the Unity. Drag the script and attach it to your player object in the same. Once the script is attached, Unity will run this code during gameplay. Now when the player gives movement input, the rigid body will receive force and the player will move. One thing to keep in mind when using AddForce is that movement may feel slightly slippery. This happens because physics introduces momentum. So the player might continue moving a little even after the input stops. In some games this is actually desirable, especially when you want realistic or physics-based movement. You will often see this type of movement used in things like rolling ball games, racing games, rocket movement, or other physics-based mechanics, where the feeling of momentum takes the gameplay more interesting. And that's the basic idea behind moving objects using AddForce in Unity. I hope this explanation helped you understand how this works. If you found this video useful, just stay tuned to our channel and I will see you in the next video. Thank you. We are going to learn how to move a player using move position in Unity. Now there are multiple ways to move an object in Unity. You can directly change its position, you can use translate, you can apply forces, and you can also use move position. Each method has its own purpose. Move position is useful when you are working with a rigid body and you want movement that works properly with Unity physics system. while still give you precise control over where the player movement. So let's see how we can implement it. First, let's create a new C# script. I will name it player movement and attach it to my player object. Now the first thing we need is a variable to control the movement speed. This value will determine how fast our player moves. So I am going to write this line. Public float speed is equal to 5f. This variable is called speed. If we increase the value, the player moves faster. If we decrease it, the player moves slower. Next, we need access to the rigid body component because move position is a rigid body function. Without a rigid body, we won't be able to use it. So let's create a variable for that. Private Rigidbody.RB. This variable will store the rigid body attached to our player. Now we also need a variable to store the movement direction that comes from player's input. So let's create another variable, private vector3 movement. This variable will hold the direction in which the player wants to move. At the moment our rigid body variable is empty. We need to get the rigid body component from the player object. The best place to do that is inside the start function because start runs once when the game begins. So inside start I am going to write this. Void start RB equal to get component rigid body. What this line does is it looks at the object the script is attached to, finds the rigid body component and stores it inside the RB variable. Now our script has access to the player's rigid body. Next we need to read the player's input. For that we will use the update function because input should be checked every frame. So let's create a update function. Inside update we need to read horizontal and vertical movement input. So I am going to write these two lines. Float horizontal equal to input.getAxis horizontal. Float vertical equal to input.getAxis vertical. The horizontal axis controls left and right movement, while the vertical axis controls forward and backward movement. These values change automatically when the player presses movement keys. Now that we have the input values, we need to convert them into a movement direction. In Unity, directions are represented using vector 3. A vector 3 contains 3 values, x, y, z. X represents left and right movement, y represents up and down movement, z represents forward and backward movement. Since our player is moving on the ground, we don't need any movement on the y-axis. So I am going to create a movement vector like this. Movement is equal to new vector 3 of horizontal, 0f, vertical. Now the movement variable contains the direction the player wants to move. The next step is to actually move the player. Since move position works with rigid body physics, we should use it inside the fixed update instead of update. The reason is that Unity performs physics calculation inside fixed update, so movement becomes more consistent. So let's create the fixed update function. Inside the fixed update function, we are going to use move position. So I am writing this line. rb.movePosition of rb.position plus movement into speed into time.fixed delta time. Let's understand what's happening here. First rb.position gives us the current position of the player. Then movement into speed calculates how far we want to move. After the time.fixed delta time makes sure the movement remains consistent regardless of frame rate. Finally, we add the movement to the current position and pass the result into move position. This tells the rigid body to move to that new position. One thing I really like about move position that we are not directly teleporting the object to a position frame every frame. Instead, we are letting the rigid body handle the movement through Unity physics system. This usually gives smoother and more reliable results when working with rigid body based objects. At this point, our script is complete. Now go back to the Unity and make sure your player object has both rigid body component and this player movement script attached. Enter the play mode and press the movement keys. You will notice that the player moves smoothly using move position. You will often see this method used in character controllers, enemy movement systems, top-down games, and many other situations where developers want direct movement control while still working with rigid body physics. And that's the basic idea behind move position in Unity. I hope this explanation helped you understand not only how to use move position, but also how we use it. Today's video, we are going to learn how to move a player using character controller component in Unity. Now in previous movement methods, we used rigid body components and physics-based movement. But sometimes we don't want our player movement to depend on physics. Instead, we want direct and precise control over the character. That's where the character controller comes in. So let's see how we can implement it. First, let's create a new C# script. I will name it player movement and attach it to my player object. Now the first thing we need is a variable to control the player movement speed. So I am going to write this line. Public float speed is equal to 5f. The variable controls how fast our player moves. Increasing the value makes the player move faster, while decreasing it makes the player move slower. Next, we need access to the character controller component because all of our movement will happen through it. Let's create a variable for that. Private character controller. This variable will store the character controller attached to our player object. At the moment this variable is empty, so we need to get the character controller component when the game starts. For that, inside the start function I am going to write this controller equal to get component character controller. What this line does is it looks for the character controller attached to the same game object and stores it inside the controller variable. Now our script can access the character controller whenever we need it. Next we need to read the player's input. Since input should be checked every frame, we will use the update function. So let's create an update function. Inside update function, the first thing we need is the horizontal and vertical input values. So I am writing these two lines. Float horizontal equal to input.getAxis horizontal. Float vertical equal to input.getAxis vertical. The horizontal axis controls left and right movement, while the vertical axis controls forward and backward movement. These values will change depending on the keys the player presses. Now that we have the input values, we need to convert them into a movement direction. So I am creating a vector 3 like this. Vector 3 movement is equal to new vector 3 horizontal 0f vertical dot normalized. Let's understand this line. The x value represents horizontal movement. The y value represents vertical movement. But since we don't want the player moving up and down, we keep it at 0. The z value represents forward and backward movement. You will also notice the word normalized at the end. This is important because without normalization, diagonal movement would be faster than moving in a single direction. Normalization makes sure the player moves at the same speed in every direction. Now that we have our movement direction, the final step is to move the player. For that, I am writing this line. Controller.Move of movement into speed into time.delta time. Let's break it down. The movement vector tells us the direction. Speed controls how fast we move. Time.delta time makes the movement frame rate independent. And finally, the move function moves the character controller in that direction. Unlike rigid body movement, we are not applying forces or working with physics here. We are simply telling the character controller exactly where to move. At this point, our script is complete. Now go back to Unity and make sure your project object has a character controller component attached. Then attach the script to the same object, enter play mode and press the movement keys. You will see the player moving smoothly using the character controller. This type of movement is commonly used in the first-person games, third-person games and many character-based projects, where precise movement is more important than physics interactions. And that's the basic idea behind character controller movement in Unity. I hope this explanation helped you understand how this works. Thanks for watching and I will see you in the next video.